Hello everybody, the main idea for today's video is going to be about graphing linear equations. We've done equations, we've done functions, and now we're finally going to learn how to graph those things. Before we start graphing, let's just talk about how there are three different common ways that you can see a linear equation. They're either going to give you an equation where x and y are on the same side. That's called standard form. In standard form, x and y are both on the left side of the equation, and then you're going to have just a constant on the right side. That's the way you know if it's standard form. X and y on the same side, the regular plain numbers are on the right side by themselves. Slope-intercept form is this is the way that you're used to seeing it. This is the way that is most commonly taught first with equations, and it has y on its own, and y is equal to m times x plus b. Y is equal to m times x plus b. M is a number that's going to multiply x. It's a special number, and we call that number the slope. Y is y, x is x, and b is just a random number. It's not that random because it's a pretty important number for b, but all you need to know is b is a number, m is a number, y is going to be whatever the answer is, and x is what we will plug in to graph this. I'm going to use this example to graph today. This is the type we're going to be graphing today. Point-slope form is the third way that you're going to be given linear equations this year. Slope-intercept form has y2 minus y1 is equal to m times x2 minus x1. The point-slope form has two y's on one side, two x's on the other, and the x's get multiplied by the slope. We'll talk about why this is in about a week and a half's time, probably. But this is what it looks like. All of these things, all three of these, we're going to talk about in a lot more detail in just about a week and a half because we're getting close to the end of 9 weeks. But by the end of the 9 weeks, you will know all three of these and be pretty comfortable with them. That's just going to take some time, but right now I'm just showing you all of the options. Each form of the linear equation has their most efficient use case. They all have what they're best for. But if you prefer any one of these, then you should be able to convert between the forms in only a few steps. It's just a few steps of rearranging things, of using your additive inverses and multiplicative inverses, and then if I gave you standard form, you should be able to turn it into either one of these other ways. Right now, you probably can't, but soon you will, and it won't be that bad. I have a small side note about these types of equations. So off to the side, or maybe on the back of the left page, please write this down. The main ingredient for linear functions is they have to have a slope. Every linear function, every single linear function has to have a slope. And that slope needs to be constant. If the slope is not constant, it will not be linear. Because if the slope is changing, constant means it stays the same. It's one thing and one thing only. If the slope is changing, then that means your graph is going to be curved. Like this line here. This line has a changing slope. The slopes of this line are alternating between positive numbers, negative numbers, and fractions, and all sorts of things. But you won't be able to talk about the slope of a line like this for a while, for a few years actually. But eventually you will. Slope is something that's super easy to find. We've already done, well, I've tried to see what you knew in the get more math pages and I saw that slope, you kind of know about it, but you're not great with it. But slope is found super easily by doing the rise of a graph and dividing it by the run of a graph. If you only know the coordinates, then what you do is you find the change. This triangle symbol, this means change. Triangle actually means, the literal translation of it is the word delta, because the triangle is a letter from the Greek alphabet. When we use it in math, what we mean is the change in something, the change between something. So when you see this delta y, that means the change between the y's. Y's are up and down. So if we're looking at this line on the left, as we go from the bottom to the top, how is the y changing? If you divide that by the delta x, which means the change between the x's, and the x's measure from left to right, this graph, as it goes from left to the right, is going upwards, but then here, it begins going downwards from left to right. From left to right, we always read our graphs left to right. Sometimes in this little tiny interval, right here to right here, it's going down, but right here to right here, it's going up. This slope changes, so it makes those curves. The slope, where this showed up a few weeks ago, is the common difference of a sequence is the same exact thing as a slope. When you were finding D before, like you used D in the warm-up, that little bit that from one part of the sequence to the next part of the sequence that changed, that is actually, in a regular equation, the slope. In a sequence equation, yes, it is the common difference, but in a linear equation, we call that the slope. And the formula, besides these top two, the formula to find slope is right here. Put a big star by this once you write it down. M equals y2 minus y1 divided by x2 minus x1. That's a super important equation, and it looks like a lot, but like I said, once you practice it, it's going to be nothing. It's just subtracting and then dividing. That's all that this says, is subtract some y's, subtract some x's, and then divide them, and that's an answer. That's going to be the slope.